Hi, in this video I will discuss about closure properties of contextual language. I will be giving voiceover for this presentation.
This is Hemant. I am pursuing Computer Science and Engineering 5th semester at Bennett University, Greater Noida. I am doing this video as a part of my course Automated Theory and Computability assignment. So let's start this video by knowing about contextual language. Contextual language is accepted by pushdown automata, and contextual language is generated by contextual grammar. Here, contextual grammar is known as generator of the contextual language, and pushdown automata is known as the acceptor of the contextual language. So, after knowing about the contextual language, let's know some of its applications. Contextual language has very wide range of applications. Especially, it have many applications in programming languages. Contextual grammar is also used in compiler design. Before going to the closure properties of contextual language, first understand what are closure properties. There are various types of closure properties. For every closure property, there are two possibilities. Either the language is closed under the property or not closed. To understand what is meant by closed and not closed, I will take an example. Here, consider the case of natural numbers. Natural numbers is a set of numbers. From this set of natural numbers, let us take two random natural numbers and perform an operation. Here, I performed addition operation between the two natural numbers. If you perform addition between any two natural numbers, the output produced from this addition is also a natural number. So here, if you perform division between these two natural numbers, the output may not be necessarily be a natural number. Take an example like 3 and 5. Both 3 and 5 are natural numbers, but 3 divided by 5 or 5 divided by 3 is not a natural number. So here natural numbers are closed under addition, but natural numbers are not closed under division. Here you should keep a note that even if you can find at least one example that is not closure, then you can say that it is not closed. It means that the language is not closed. Here the addition operation is closed, but the division operation is not closed. In this video, I will discuss 5 closure properties of contextual language. They are union, concatenation, clean closure, intersection, and complementation. Out of these closure properties, contextual language is closed under union, concatenation, and clean closure. But contextual language is not closed under intersection and complementation. So before discussing each of these properties, first understand the terminology of contextual grammar. Contextual grammar is denoted by 4 tuples. They are V, sigma, S, and P. Capital V is the set of variables, also called as non-terminals, and sigma is called terminals or input symbols of the grammar. S is the start symbol, it is a special symbol, and P is the production rules of the grammar. So now let us start with union. The first property is union. Let L1 and L2 be two contextual languages. Then L1 union L2 will also be contextual language. Suppose L1 and L2 have corresponding grammars G1 and G2. G1 is denoted with tuple V1, sigma 1, P1 and S1. Similarly for G2, with changing the subscript from 1 to 2, G2 is denoted. For the grammar L1 union L2, grammar is found by G. It is denoted as capital G. It is the union of G1 and D2. That is, G is equal to V1 union V2 union S. Here S is a new symbol. It is introduced for this L1 union L2, and the sigma is sigma 1 union sigma 2. Here P is equal to P1 union P2, and also an extra production that is as simple as S1 or S2. Here the start symbol is capital S, the new symbol. So let us take an example. By taking two contextual languages L1 and L2, L1 is equal to a power n b power n where n is greater than or equal to 0. L2 is equal to b power m c power m where m is greater than or equal to 0. Here L3 is generated as L1 union L2, which is a power n b power n union b power m c power n where n and m are greater than or equal to 0. Here L3 is also a contextual language because here the contextual language can handle one dependency at a time. So by using union, we can have two paths. One path can handle a power n, b power n, one dependency, and other can handle b power m, c power m. By going to the next property, that is in concatenation, also we will follow the similar procedure as followed in union. L1 and L2 be two contextual languages, then L1 and concatenation L2 will also be a contextual language. By taking the same example from union, L1 and L2 and G1 and G2 are corresponding grammars for L1 and L2. The grammar for L1 dot L2 will be V1 union V2 union S. Here S is new symbol, which is as simple as S1 or S2, which is also included in the new production of the L1 dot L2. Now let us take an example for concatenation. By taking two contextual languages, L1 is equal to a power n, b power n, and greater than or equal to 0, L2 is equal to c power m, d power m greater than or equal to 0. Then the concatenation L1 dot L2, which is also denoted as L3, is equal to a power n, b power n, c power m, d power m, where n and m are greater than or equal to 0, which is also a contextual language. The grammar for L3 will be the all the productions for including the productions of L1 and L2 along with S3 implies S1 S2. For L3 we can create a push down automata which will first push A's and pop B's. After that it again push C's and then pop D's. It shows that we can create a push down automata for L3. So L3 is a contextual language. Going to the next property, clean closure. Let L1 be a contextual language, then L1 star will also be a contextual language. Here L1 with the grammar Z1 is denoted by V1, sigma 1, P1 and S1. Now the grammar for L1 star is denoted by V1 union the new start symbol S. For the production rules of the new G will be the productions of all the productions of L1 along with the production S gives epsilon or SS1. That is the new production for G, and the remaining input alphabets is the same for both L1 and G. Let us take an example for clean closure so that we can say that clean closure is closed under for contextual languages. Taking the contextual language L1, a power n, b power n, where n is greater than or equal to 0. Here the L1 has the corresponding production rule, which is S1 gives A, S1, B or epsilon. Then the clean closure of L1, which is also denoted as L, is equal to A power n, B power n and greater than or equal to 0 whole power star. Here star indicates that the language can repeat any number of times. Here L is also context free. The corresponding grammar for L is it contains all the productions of L1 and along with the new production S gives S1S or epsilon. Till now we have seen all the properties in which contextual language is closed. Now we will see in which contextual language is not closed. Here L1 and L2 are two contextual languages. Then L1 intersection L2 is not necessarily context free. Let's take an example. L1 is equal to a power n, b power n, c power n, where n and m are greater than or equal to 0, and L2 is equal to a power m, b power n, c power n, where n and m are also greater than or equal to 0. Here, so L1 and L2 are two contextual languages because there is only one dependency. By taking intersection of L1 and intersection L2, which is denoted as L3, the corresponding language will be a power n, b power n, c power n, where n is greater than or equal to 0. Here, the language L3 has two dependencies. One is number of a's and b's should be equal, and the other dependency is number of b's and c's should also be equal. As informed earlier, that context tree languages can handle only one dependency, but here the language L3 has two dependencies. So as already informed earlier in this video, that if we can find at least one example which does not accept the closeness of the property, then we can say that context tree language is not closed under the particular property. So intersection is not closed for the context tree language. Let us see the case for complementation. If L1 is a context tree language, then complement of L1 is not necessarily context tree. Let's prove this proof by contradiction. We can represent L1 intersection L2 in the following way. Complement of L1 union complement of L2 whole complement. Let us assume that context tree language is closed under complementation. So in that case, the complement of L1 is a context tree language and complement of L2 is also context tree language. That implies complement of L1 union complement of L2 is also context tree language. It shows that the whole L1 intersection L2 is also context tree language. But we know that L1 intersection L2 is not context tree language. So it is false. It shows that complementation is not closed under context tree language. Thank you.